Okay. Okay. There we go. Cool. All right. Give everybody a couple minutes. To get back on. All right. So give everybody a minute or two to get back. All right, we're getting there. We're getting some people back in. Still only got a couple people, so we will continuing. Wait for everybody to join in. While we're waiting for everybody, I'm going to look up what that raccoon thing is. That's what we shall do while we wait.
I'm gonna have a call the ice cream truck tell him I can come.
Okay, so Sarah, the raccoon talks to the key management protocol to establish security associations with other hosts. Raccoon sends all informational messages, warning and error messages to system log and the log daemon. So the raccoon sends messages when we have security issues talking to the network. Why it's called raccoon? No idea. All right, we still only have a couple people, so Raccoons have a lot of responsibilities. Useful trash panda. I love raccoon guys. I think they're so cool. They're very neat. I love their little tiny hands. I really like raccoons. I think they're neat. I understand that they're like a pest and they like transmit diseases. Like I get it. And I understand that they'd be bad pets. I know. I still think they're really cool. All right. How many people we got? We're getting there. We're getting up. All right. Let me everyone go. All right. So let's talk about environment variables. Environment variables are just ways for us to set up our either development environment, a server environment. And what we mean by environment is just like setup. So like either your desktop computer or a server or a virtual machine or just one user logged in under one particular way is an environment. Variables in our environment it tells the system what to run. So if you look at your path, in Windows, I think it's a little bit easier to see than in the Linux systems. I don't know how to see it actually on my computer. I've only ever done it on the Windows machines. Oh, thanks, Sarah. I don't know why I'm not in it today. Thanks. Okay, there we go. All right, can you guys see the thing now? Whoa, my computer's freaking out. Yes, excellent. Okay. Excellent. Excellent. I have to move everything again. Will that be? Okay, awesome. All right. So environment variables, it's part of our config stuff. So it's setting up like, hey, this is where MySQL runs. Hey, this is where like the actual file location for Visual Studios is. Hey, this is where my operating system is. And it just sets up all of these tools for us. I think like your language configuration is part of your environment. So like, hi, I'm an English speaker, and it'll put that in there for you. This is talking about how to do it in React. I don't super care. It does talk about it though, which is nice, and it gives you those. What I really care about though is I want to see like, can't see that. What is that? What screen am I sharing? I don't know why I'm not in it today. I'm sorry, guys. I'll get my life together, I promise. Flip over to this one. Okay. So you guys should see Google right now. Okay, great. Might be, guys. I don't know why I'm not in it. How to see path on Mac. There we go. This is what I want. Okay, great. Do I not get to see it? I guess it has to be in all caps. Cool. Okay, so what does this tell us? This tells us a lot of stuff. So this says what kind of version of Python I'm using. This says, what else? What else we got? That I'm using Wireshark. It has all my Wireshark set up. I wonder if there's a way for me to see all the other stuff. Their stuff's written out better, but can I go to the end maybe? Yeah, so Wireshark and all that, and it just has all of our path variables set up. Windows uses this a little bit more, and so you might have seen it before, like adding path variables and all that, especially like if you're trying to get like Visual Studio to work or something, you might have changed your path variables, just so you can see that. Environment variables are just telling your computer system, whether that's your operating system, your server's operating system, an instance of Node, whatever your environment is, what you expect it to do. So you're just handing it things like, this is the version of PHP I want you to use. This is the database I want you to use. This is where I want you to save files. And you just handed all of that information in this environment variable thing. And it's different for all of them. Windows is a little bit easier to see all their stuff. Linux, it's just, you know, you ask it for it. And then that article has how you do it in Node. Do you like super need this? You will when you break it. You guys will probably use this when you're like setting up new systems. You'll be like, why is this not saving something where I expect it to? And you'll play with this kind of tool to look for it. Cool. Yeah. Any questions about like environment variables? UTMS, okay. Yeah, it's just another tool that we use typically like, yeah, I think not yet is a pretty good answer, Jamila, because like, you'll be like, yeah, man, totally, I know how to set it. A path is how we store the environment variables. So a path is the way for the environment to be able to read what the variables are. Also, that sometimes when they get called, they'll get called path variables, especially in Windows machines. They'll be called path variables. I don't know if that's technically the right thing to call them. It might not be, but I've heard of them called that, and I've referred to them as that too. So a path is just a specific one. I'm sure there's other ways to set environment variables that are not paths, but that's typically what I've seen done. Cool. All right. We're picking up the pace. I'm excited, guys. All right. You see, that's the end of week 8. We can see it. We can see the end. Exciting. I mean, I guess not quite. We go all the way toward that section. Why say Windows machine and not Mac machine? What are you asking me? Like why I call it a Windows machine and I don't necessarily call it a Mac machine? I don't know. I think it's just how I've heard other people say it. And sometimes I'll call things boxes too. I think it just depends on what I've heard people say. Yeah, I don't know. But yeah, when I call things boxes, I'm talking about like a server or something too. If I say that instead of machine or server. But I don't know why I don't say Mac machine. I normally just say Windows machine, I guess. I don't know. That is a good question and I don't have a good answer for it. All right. So yesterday we talked briefly about different ways of interacting with our server to get stuff set up. older ways of doing it with FTP is unencrypted, and so this is a bad idea. So now we use encryption. Can anybody give me like a definition of what encryption is? Like in general, top level, what is encryption? Secure stuff, okay? Changing characters, I like that. To rewrite into a code, yeah. Code that can be read with a decoder. Ooh, I like that, we're getting there. Yeah, so encryption is just a system of Enigma machine, yeah, we'll talk about that. Encryption is a way of concealing information that can be unconcealed later. I'll spend a lot more time talking about like the history of encryption and that kind of stuff. Lava lamps, encryption is lava lamps, yeah. But encryption, like you kind of do encryption all the time, no matter what you think about it. Like, you know, maybe like when you're talking around a child, you might spell words out instead of saying the words. That's encryption. Yeah, the security video with the lava lamps. Yep, yep, yep. I knew what you were talking about, Sarah. Yep, yep, yep. The most famous one is like a Caesar shift. Oh, there we go. This one's done recording. Excellent. Thank you. Great. Okay. Away. Go away. Caesar shifts actually are like, if you want a fun JavaScript project to really tease your brain and really understand how everything works, I highly recommend building a Caesar shift in JavaScript. So a Caesar shift is one of like our old boys of encryption. And all it means is we just take sentences and we shift each letter on the alphabet by a certain number. So like in here, we have and look, it gives us all of these things. So if we do 3, this is what it does, and it just goes through and does all of them. This, exactly. Yes, that's Caesar. Yep, yep, yep. Decoder ring, yeah, exactly. Yep, yep, yep. These are really cool little tools, and like this was really like, this worked for a long time. One of the things that we talk a lot about in encryption is, first of all, nothing is perfectly secure. And I've told you guys this before, and like when I see people say things like it's secure, I'm like, is it? Because it's not. The biggest thing that we care about with security is how long does it take for us to break into a system? Because there is no perfectly secure thing. It's just, is it worth it? Using a Caesar shift, even if you do it by hand, will only take you a couple minutes to figure it out. Because I mean, like, you know, you can go through and be like, okay, and find out all of this stuff. This is like kind of like our basis though, is that it's just a thing. Like it's a little system of changing text into something that's been encoded that you can safely transmit and let other people see the encoded information, because it doesn't mean anything to them without the decoding abilities. And then you get to decode it, and then you have the information that hasn't been compromised. This is our like base level one that we see a lot. It's in general called a substitution cipher. It just means that you're going to use something different to stand in place. This isn't what we use anymore. You can also Caesar shift multiple times. You can shift each individual space by different things, and all that. What's that? We'll talk a lot more about this at our security week at the end. I just want to give you guys a nice base. That's not what we use anymore, but that's kind of like our like history set baseline, is we've been doing this for a long time. And we only need our things to be so complicated enough that it's not worth putting the time into it. There's been a bunch of different encryption methodologies. We have MD5, I think SHA. The one that we use a lot now is RSA encryption. This tends to be the one that gets used right now. And all it is just like the Caesar shift, is just a set of ways to get to our new code. RSA is just a new set to get encrypted data. It's an algorithm. Algorithms just mean that it's a series of steps. The other thing is RSA doesn't stand for anything. It's the dudes' names who made it. And they also kicked out one of the dudes who helped make it, which just amuses me. Yep, there's another dude and they got rid of him. I'm not gonna go super in depth into how all this works. I think it's really cool and like it's something that like I really enjoy. Mostly all you need to know is data needs to be encrypted in transit, and if you are storing things like passwords or other PII, personally identifiable information, it needs to be encrypted at rest also. And your encryption keys should not exist in the same place as your encrypted data. You'd think that these kind of things would be obvious, but they are not. So this is what is kind of the standard right now. I will say one interesting thing that people are thinking about right now is because of quantum computing, this kind of math is about to get much easier to do. And so a lot of people are really worried about what in the next couple years does encryption look like, because right now all of our encryption systems are on the bias of being able to be just as easily broken as if we were just using a Caesar cipher to secure all of our data. So that's a really cool thing to like read about and see what's going on. At this current point, we're still using these encryption standards. It's the best we have right now. Quantum computing, all right, it's a little bit of a derailment, but I think it's really cool, and we spend a lot of time talking about this later, so it'll be okay to talk about it now instead. Quantum computing is, so we've talked about how on our fundamental structure that computers can only hold a 1 or a 0 in a transistor. And that's the fundamental system for all of our computers. It can either be a 1 or a 0, and that's it. With quantum computing, we get to use a lot of weird physics stuff to basically exist in more than one state at a time. Which, like, if this is like melting your brain and you're like, what? Don't stress about it too much. Spooky action at a distance. I kind of like that. I feel like that can be like world history. Spooky action at a distance. And what quantum computing gives us, so instead of having something that can only physically exist at a 1 or a 0, we get to suddenly do, quantum entanglement, And so we get to exist in more than one position at a time, which means we get to run more than one computation at a time. We are in like the baby infant steps of this right now. Like, I think Google's been like, we can turn a quantum computer on, and they've proven that it works, and that's about it. But because these can do so much faster computation than a traditional computer, a lot of people are worried that quantum computing is going to fundamentally break encryption. Because right now, encryption works because it takes too much time to unencrypt data if you don't have the key. But if it's suddenly a lot easier and faster to run math, then instead of taking like, I think manually breaking RSA encryption takes like thousands of years, but assuming quantum computers work correctly and we can get it to work, what would take thousands of years now will take seconds. And seconds are totally worth breaking into any system for. Like, you're telling me I can break into the IRS in seconds? Sure. You're telling me I can break into like, Amazon and get every piece of information from them? Sure. In seconds? Yeah, that's worth it. How big this threat is debated really hotly right now. Some people think that it's not going to matter for years. Some people think it's a like pressing matter that we got to figure out like now. And other people are like, it's not going to happen. It's never going to work. So we'll see. going to use this derailment to talk about something else that I spend time with later talking about. In order to like keep up to date on stuff, this is a website that I think I've showed you guys before, but I think now is a good time to reiterate this. It's called The Next Web, and they talk about a lot of this stuff and like what is the newest, hottest things going on in technology, web development, all of these things. Some of them are kind of like opinion pieces, and then some of them are more like, you know, good resources and all sorts of stuff. So I highly recommend this. Just, you know, kind of check in every now and then and just see what's up. It can be a really useful tool to look at. Go away. But yeah. And like, don't worry if like none of this piece made sense. Don't worry about it at all. This is just like a cool side note thing. No stress at all. We'll talk more about encryption. Our last week of content is when we talk about all the security concepts in detail. So, no stress. Yeah. Cool. So besides like really technical questions, because I don't want to like, I'm not a quantum computing expert. I just am aware that it exists and like the fundamental like why we think it's cool. Any questions about that little derailment? No? Okay, cool. Yeah, and again, like not super fundamental, but I think that's really cool. And like, if you're interested in like the cybersecurity stuff, it's definitely something to keep your eye on. All right, so I'm not gonna watch these videos with you guys. This is Khan Academy. I love Khan Academy. You don't have to watch all of these. I think they're really nice. They're all like 3 to 5 minutes long. They're really cool and they've really set a really good fundamental base for what all of encryption is. And it gives you little like challenges so like you can like play through it and all that. What I would look at fundamentally is this modern cryptography section. Again, do you need to watch all of them and be like an expert in it? No. But this really sets a really good basis for how SSH works. This explains to you in depth about why we learn these and like how we use them and why they work. So I recommend watching them. Yeah, Khan Academy is great. Listen, Saul Khan, primo dude, linear algebra, him, calculus, highly recommendo. There is also a JavaScript section, and it focuses mostly on animations. Yeah, Sarah, it saved me in college for so many classes. Same. Crash Course in Khan Academy. I appreciate them for my degree. They helped more than most of my teachers. Yeah. The JavaScript section in Khan Academy is geared towards younger viewers, and it mostly focuses on like doing little animations, but it is like a pretty chill environment. I also didn't like listening to the girl who teaches it. It's not Khan talking, it's a woman talking, and I don't super like her voice, but it does take you like super like base level, like here we go, and gets you to like making really cool animations with JavaScript. So it is a fun little course. But yeah, so this is the section I would recommend, is this one. And you don't necessarily need this if you're interested in the math. This is the math, how all of this stuff works. You get badges for editing code and making stuff. Yep, Sarah, yep. And they're fun little things because you could just copy all the code and put it on your code pen and then bam, talk about it when like you do interviews and stuff and be like, look at this cool little animation I made. Or put them on your website. The primality test and modular arithmetic goes very in depth about how the math works. You don't necessarily need them. I think it's really cool. And this time-space trade-off, I think, is the fundamental piece of why we care about all of these, is because it explains, got derailed for a second, and now we're on math. Yep, that's how it works. We're just talking about the math behind why encryption works, and this is a bunch of resources for it. This is in your syllabus. So you have all of these pieces. This randomized algorithm section is pretty cool. The piece that I would really, really recommend is the modern cryptography section. That's the only piece I would be like, you really, really should watch this. I recommend watching all of it because I think it's really interesting and it really shows you how all these pieces work in like a really accessible way. Like, I don't think anything in this is overly complicated or what you call it. It's not like talking down to you. I think the JavaScript section is a little bit, but the rest of them I think are really nice. They do also have algorithms, which are what we're going to talk about the rest of this week once we finish week 8. So highly recommend. And how the internet works and how computers work. This is the computer science section. All of them are really nice. None of them are really long. They give you a really nice basis for all of these things. So if you're interested in like another section in here, I highly recommend spending time in it. It's free. Khan Academy is just, it is genuinely like the reason why like I passed college. Also, if you're interested in anything else, they got you. So there was also a point where I was so bored I was going through all of the math, as you can tell by the half done with kindergarten math. Boredom will do terrible things to you. But yeah, it's free. You can go all the way to DiffyQ and linear algebra with math, or you can go all the way to like, please teach me algebra because I don't remember algebra. So it's nice. Cool. All right, close. Go away. So we only got like 5 minutes left before we go. Any questions about what I'm expecting for you guys today or the rest of this week? Okay. Alrighty. Yeah, so we'll talk about PuTTY. I guess I can hit it pretty quickly and we'll finish up. If you are trying to SSH into a server from Windows, all right, so I said, Sarah asked, no stress about the week of homework, but should we be getting that done? When should we be getting that done? I would lower your priority for it for the group project. Your group project should be your highest priority right now. Because I'll let you guys have that makeup week at the end. You have, I think week 11 and 12 don't have a lot of homework, so you can do it then too. So I wouldn't stress about it too much. I'd focus on your group project for the next 2 weeks. Then you have spring break and our makeup week and all that. So I wouldn't stress about it too much. I'd focus on the group project. Okay. So if you're trying to SSH into a Linux server from a Windows machine, you need to use this piece of software called PuTTY. It's free. It looks like an archaic piece of garbage from like 1992, but it's pretty easy to use. And instead of just like opening up your CLI and being like SSH into the server, you just use PuTTY to do it. Do I care about anything else? I don't think so. You describe me so harshly. What do you mean, Sarah? 90s. I'm a 92 baby. Oh, I'm sorry. Just nailed it right on the head. That's funny. No, listen. old Windows things, it gives me both a wave of pain and nostalgia. So PuTTY will do that for you. But yeah, it's a nice little easy tool for, that's what it's for. It's for taking Windows machines and getting into Linux machines. There, I said Linux machines too. I don't know, I'm not gonna say Mac machine though, I don't know why. I'm gonna be self-conscious about it now. But yeah, this is how to download it. It's not too hard to use. I don't think you necessarily like need it for anything that we're doing. But I just want you guys to be aware that you can't make two different operating systems just talk to each other immediately. You need to have some kind of intermediary. And for Windows to Linux, you use PuTTY. Groovy. PuTTY also will generate keys for you, which is very fancy. Cool. Alrighty. That gets us through that section. So hopefully we can finish these two guys tomorrow, and then we'll start week 9's content. And you know, we'll be a couple days behind, but I'm not stressing yet. Might be a little bit stressed, but I'm not stressing yet. All right, cool. Any questions before we end lecture for today? Cool. Alrighty. Well, I'll be reaching out to you guys. I'm gonna talk to Hardcore real fast and make sure that he's actually still supposed to be working. I'll get that taken care of and figure it out. And then I will be slacking you guys your grades, and I will be slacking you guys when we do code review. Okay, I will talk to you guys later this afternoon. Bye.